Well, hello, good morning, everybody, and welcome back to Saturday at SQL Bits. It's great to see everybody here. We're going to be talking about Azure SQL Edge this morning. My name is Kendall Van Dyke. I'm a senior program manager on the SQL Server team, and I run the early adoption program for SQL Server 2022. I'm also responsible for the Azure SQL Edge product that we have. So today, we're going to talk about SQL Edge, what it is, what it isn't, and I'll give you a brief introduction to how to get started with Edge. Now, Edge itself is almost like an entire platform. It would be like saying, hey, we've got SQL Server on IaaS VMs, and I'm going to tell you everything that you need to know about it in 50 minutes. That's just not possible. So today we're going to just cover an introduction to what Edge is and how it works, and I'm going to point you to some resources where you can get started and try some of these things out for yourself. So we've got lots of demos, but first, let's cover what the heck Edge is to begin with. And let's start by talking about the Edge in general. Now, Gartner has published some numbers that say that by 2025, 75% of enterprise-generated data will be created and processed at the Edge. That's a huge increase from where we're at today. IoT adoption has grown all the way up to 91% from 2019 to 2020. And we see that IoT is an important strategy for many companies. It's an important element to many of their business, and 90% of organizations consider IoT as critical to the overall success of their business. So IoT adoption is not going to slow down. 2 years from now, we think 95% of organizations are going to anticipate using IoT just as much, if not more, than they do today. So what the heck is IoT, right? We're talking about small devices that generate data. Data comes from all kinds of places. Data comes from thermostats. Data comes from pallets on shipping floors. It comes at manufacturing facilities from sensors that are gathering data. All of this data has to be processed somewhere, and that's what we're talking about here is IoT-related data. It also generates massive quantities of data. If sensors are reading something off of a manufacturing floor, for example, every few seconds, you can imagine that it's going to continue to generate lots and lots of data if we have lots of sensors on the manufacturing floor. Yes?
Just a quick question. Would you consider a till in a supermarket?
Yeah, good question. So would a till in a supermarket be considered an edge device? Sure, absolutely. When you think about an edge device, it's usually something that's a low-powered, low CPU kind of system that doesn't have a high amount of usage but needs to process data locally, and it may need to process it in a semi-connected or disconnected scenario. So a till at a grocery store, absolutely. A windmill that generates data, any of those kinds of things would qualify as edge devices. You need some kind of on-device processing to work with that data, to serve an application, and then to do something else with that data, maybe send it somewhere else for processing. And that brings about a few challenges when we talk about the adoption of IoT. First is, if we were to break this down across the categories of challenges, the first is there's infrastructure issues. Where do you host these devices? How much CPU, how much RAM do these devices need? What kind of data processing needs do they have? Then there's network connectivity. Are you in a semi-connected scenario? Are you in a disconnected scenario or a fully connected to the internet scenario? And then of course there's data. You have to process this data somewhere, somehow. So we're going to focus on the data portion of this today because we're talking about Azure SQL Edge. Now, Microsoft does have a full stack. It's called Azure Stack or Azure Edge Stack. And we have full capabilities of devices that can process everything end-to-end, applications all the way through data. We're going to focus on the data because we're here talking about SQL Edge specifically. So let's take a look at some of the challenges around that data landscape specifically. First is that connectivity we mentioned. If you have a dependency on an internet connection, and that connection gets severed, you have an issue. All of a sudden, you can't host your data. So Azure SQL data is fantastic. You could put a database in Azure or in a cloud provider, but if you've lost that connectivity, you're down. I'll use an example. I'm from Orlando in Florida, and we have a place called Disney World in Orlando. Could you imagine what would happen if Disney relied on connectivity to a cloud provider, and suddenly connectivity got cut, and they had to tell everybody at the entrance to their parks, I'm sorry, we can't let you in today to the happiest place on earth because we can't connect to the cloud. That would be very bad. So IoT applications need to be able to function offline. Autonomous vehicles, for example, that are located in remote parts of the world that don't necessarily have connectivity have to make decisions based on sensor data that's available to them at the time, and then maybe even apply some ML on top of that. And you can't rely on an active internet connection in that scenario. Latency is also an issue. There's a time delay sometimes between an action and the response to that action, and that can be significant in cloud applications because of the round trip that the data has to actually make. So you need near real-time responses. It's critical in a lot of IoT use case scenarios. In the case of a factory floor, for example, we have decisions that need to be taken spontaneously by machines on the assembly line. And latency in these cases might result in a loss of a lot of money for certain customers. Data security and privacy is another issue. There's risks associated when transferring data through the network as opposed to just keeping it right on device and keeping it local. So security is prevalent across every industry vertical. We don't want to leak data. We don't want to end up in the news because we leaked data, especially in verticals like healthcare and financial services. Security solutions are incredibly important in those scenarios. Broadband is another limitation. Just bandwidth in general is another limitation. We're getting broadband across the world. Things like Starlink satellites, for example, are bringing that to the world. But the more bandwidth we have, it seems like the more we like to use it, the more data we like to generate. So the growth of data volumes in IoT devices are going to start exceeding the speed at which broadband infrastructure can be extended. We're going to outpace the rate at which broadband is being extended across the world. And that puts a hard limit on the growth of applications that depend on the cloud. So what happens when you have to take decisions on, say, a ship that's in the middle of the Mediterranean? You need something on device. You don't want to rely on the very limited bandwidth in those scenarios for a cloud-based application. And then finally, there are costs associated with the cloud. The more data that gets sent to the cloud and stored in the cloud, the more the cloud costs. It's a pay-as-you-go type of scenario. And many companies who are just getting into the cloud don't always do it right. They find out that it's a little more expensive than they anticipated if they don't scope it out right ahead of time. So these are some common challenges that we face with IoT data specifically. So this is where SQL Edge comes into play. We need to speed up the collection of data. We need to reduce the risk of losing that data. We have to collect it, we have to aggregate it, we have to synchronize it, and we have to process it as close to the source of data as possible. And that location is either going to be on the device itself, or it's going to be on a computer that's on the edge network, staying within the same network as where that device is located. And this is the point in that data management lifecycle in which databases specifically built for edge computing become really, really important. You might be thinking to yourself, why do I need a database for the edge? Right? Why can't I just go spin up, say, if I'm at a factory floor, a server on a rack in the back of the factory floor and go throw a SQL Server Enterprise on that? Well, that might be overkill in certain scenarios. Think about those semi-connected or disconnected scenarios where I'm out in the field and I've literally got a device on my back in a backpack and I need device processing capabilities. I need data processing capabilities. So an edge database has specific features that make it easier for the applications to focus on adding your business value rather than implementing some specific processes for integrating, collecting, and aggregating all this data at the edge. Then we can just collect it there at the edge, and we can process it right on the device, and then we can deliver the results of that processing out to the cloud for analysis later, or back to our on-premises data center in that case. So an edge database can help automate a lot of these features, even if your networks happen to be intermittent or slow, or you don't need the full-blown enterprise-class SQL server sitting on a rack in the back of the room. So this is where we bring into the picture Azure SQL Edge. Azure SQL Edge has been developed by keeping these challenges in mind. It's an optimized relational data engine that is geared specifically for IoT and IoT Edge-based deployments. So we have capabilities that allow us to create a high-performance data storage and processing layer for all these IoT applications and solutions. Now here's the cool part. It's SQL Server. If you know and love and work with SQL Server, you're going to be right at home with Azure SQL Edge. It's been built on the latest versions of the SQL database engine. It's got the same industry-leading performance and security and query processing capabilities as enterprise class SQL Server, but running on a low-powered device. So Azure SQL Edge is built on the exact same engine as SQL Server on premises, as SQL on Linux, as SQL in the cloud. So that means it provides the same T-SQL programming surface area. That means it's easier to develop applications, and you can develop them easier and faster. And it also means that your applications are portable between IoT devices and data centers, both from IoT all the way up to the highest scale enterprise class. It is a fully contained solution. The keyword being contained. It is a container-based version of SQL Server. Now I'm curious, how many people have used containers with SQL Server? A few hands in there. So containers we introduced in 2017. Containers are Linux-based, and it allows you to run SQL Server on Linux within a fully contained environment, whether it's on your desktop or on, say, a small device that has Docker running on it, or you can run containers out in a cloud provider or in Kubernetes. Okay? And it's a portable format, basically, to say I can create a database inside of a container, and it's in its own little world, and it's got the full processing power of SQL Server, but it's running in that nice little contained environment. Not only can we run on x64 architecture, so that's Intel and AMD devices, but we can also run on ARM64 devices. You may have heard Azure SQL Edge when we first introduced it. Great case scenario was it runs on a Raspberry Pi. Anybody played with one of those? Right? I love Raspberry Pis. I think they're pretty cool. As long as you can run Docker and you can run containers, then you can run SQL Edge. It is, since it's SQL Server, it's providing the exact same tooling and developer experience, whether you're working on the Azure SQL Edge or whether you're working on SQL Server itself. This can run on devices from IoT devices to edge servers, but they do have some minimum requirements. So 2 cores and a few gigabytes of memory are generally the required amount for that. But come on, look, I've got a phone in front of me. How many cores do we have on modern phones now, and how much RAM do we have on board these? Most devices nowadays have got that minimum amount of RAM, right? So there's a few use cases. You're probably thinking through your head. We talked about this earlier. If tills at a grocery store, for example, were an applicable use case. So here's a few use cases where Edge makes sense. Think about manufacturing floors that I mentioned, where you've got telemetry data that's coming off of sensors as things are passing through that floor. You've got the need to maybe predict if you've got a sensor that is reading out of spec, and you need to do something about it before you shut down the manufacturing line. So you can optimize your assembly line there as well. If you have, for inventory tracking, for example, you can optimize your inventory and start doing forecasting right at the edge as well. So if it looks like you're running low on a supply at a station, then you can predict that you're going to need more of that at that station. You can stream that data as well. So if you have manufacturing data that's being generated by lots of sensors, and you'd like to stream that to a more powerful server for processing in real time, we support Azure Stream Analytics integration with Edge. For energy and power scenarios, think smart grid, electric grids, right? We want to predict if there's a surge in energy, or if we have windmills that are generating data. We'd like to know if a windmill is producing the same amount of power as all the other windmills, okay? If, I'll use the till example, right? If we have a till that suddenly is underperforming, maybe there's an issue and it's not sending in the data that's being collected to it, we need to raise attention to that and go and do something about it. Okay? In healthcare, there's all kinds of devices in healthcare that are IoT types of devices. Patient monitoring systems, for example, that sit right at bedside. You would like to know if there's an issue with a patient's healthcare. Suddenly their heart rate changes or something else changes where you need to alert based off of a condition in real time. That's the kind of scenario where having that fast processing is absolutely critical, and you don't want to wait, in some cases, minutes, maybe the difference between life and death for a patient sitting in a hospital. Okay. So there's lots of different use case scenarios where this makes sense, and gosh, every year it seems like there's new devices and new scenarios that keep coming up for processing these. So the world of IoT is just exploding. So we have a few special things that we built into Azure SQL Edge to help support some of these scenarios. The first of which is that we provide a consistent SQL code and options for native data movement. And the challenge associated with this is, how do you implement data from the edge and get it to the cloud from on-prem scenarios? Right? So we talked about on-device processing, but we also want to maybe look at all the data across all of our factory floors in a centralized scenario. We've got a SQL database that we're streaming this all to, for example. So when it comes to IoT, we want long-term data storage capabilities for analysis over a longer period of time. And so we can move that data either through a streaming layer, or we can implement some kind of batch processing to different targets. I'll pick on Azure. I'm a little biased. But maybe you've got an Azure SQL DB where you're sending that data to, or Cosmos. Right? So Azure SQL Edge currently supports a model that supports bidirectional data movement. We also have native integration with other Azure products. So you get services like Azure IoT Edge and Azure Stack Edge. And all of this allows you to use the entire Azure ecosystem so that you can use other services to process your data beyond just processing the data on device itself. Okay. Another challenge is about the platform. Right? It used to be that if you wanted SQL Server, you'd have to run it on Windows, and you'd need a server and a rack. And on-prem was the only way that you could run it, and you needed lots of memory and lots of hard drive space. Well, that's not going to work for IoT devices. Most IoT devices are these low-powered, low CPU, maybe even something sitting in your backpack kind of scenarios. So they're not always x64 based as well. So we have ARM64 support. So we have expanded device architecture coverage with Azure SQL Edge. And you can run this on Windows or Linux because it's a container-based solution, and there's Docker runtimes for both Windows and Linux scenarios. If you have Kubernetes, it doesn't matter if your Kubernetes is running on-prem, if it's running on a laptop, if it's running in a data center, it doesn't matter. You can deploy a SQL Edge scenario or a container-based version of SQL Server to a Kubernetes cluster as well. Okay? And you can also run SQL Edge in an offline or an online scenario to support your various edge environments, right? If you're in a backpack out in the field and you're wandering around collecting data after an earthquake, you might be in a disconnected scenario versus a manufacturing floor where you're in a connected type of scenario. Okay? The next challenge is, how do we predict what's happening with data at the edge? So as we see an increase in adoption of IoT and edge computing across various industries, there's an increase in the number of devices and the data that gets generated from those devices. And that increased volume of data and the number of device endpoints, it creates a challenge for us because we have security that we have to worry about on that data and the data on the devices. We have to worry about securing that and processing that. So just like SQL Server and Azure SQL, securing your Azure SQL Edge deployments can be viewed as just a simple series of steps that involve the platform, authentication, objects, which include the data, and any applications that actually access that system. So we support on SQL Edge, just like we would for SQL Server, transparent data encryption and always encrypted capabilities. So if you'd like to keep your data secured end-to-end and encrypted on the device at rest, you can leverage TDE for the encryption piece, and then you can leverage the always encrypted to keep that device secure for the connectivity between the clients that are talking to that device and the device itself. We also have role-based access control and attribute-based access control in the Azure portal. And if you have data classification needs, this also fits perfectly into your security regulations and compliance for data classification because it's SQL Server. Okay? When it comes to performance, that's another issue that comes up from time to time is we're optimizing SQL Edge for low-powered devices. So when we say you need 2 CPUs, you're obviously not going to run something like Stack Overflow off of 2 CPUs on an edge device, right? But it's perfectly suitable for scenarios where, say, a till, where you have a few of those in a store that are generating data, or if you have 50 windmills on a wind farm that are sending data into that device. So we've optimized IoT Edge, or Azure SQL Edge rather, so that we can have fast recovery. We support column store indexes in SQL Edge, and compression is enabled by default on SQL Edge. Now, there are some interesting new things that are unique to SQL Edge that solve another challenge, which is, what do you do about continuous streams of data? So SQL Edge provides built-in streaming capabilities for real-time analytics and complex event processing scenarios. And that streaming capability is built on the same constructs as Azure Stream Analytics, and it's got similar capabilities as the Azure Stream Analytics and IoT Edge. The streaming engine for Azure SQL Edge is specifically designed for low latency, resiliency, and efficient use of bandwidth and compliance. And we support streaming through IoT Edge, IoT Hub, and Kafka clusters as well. And we're always working on improving the source and the target pairs that can be used to help improve the streaming capabilities to make it even more efficient. When it comes to time series data, it's twofold in Azure SQL Edge. So we have time series capabilities that are already available in Azure Stream Analytics, like windowing and aggregation and anomaly detection. But we've also added capabilities to the SQL engine itself, and these are coming to SQL 2022, by the way, around time series specific functions and storage optimizations. So you can group data together in buckets, for example, and process using native T-SQL time series related data right on device in a language that you're familiar with without having to go outside of the box itself. And Azure SQL Edge has another kind of unique capability here. We've built in machine learning and analytics capabilities by integrating the open format, it's called ONNX, Open Neural Network Exchange runtime. So if you have an ONNX compatible model, most ONNX models can be run right on device with Azure SQL. And this is going to allow you to exchange deep learning and neural network models between different frameworks. So we can train a model outside of the SQL Edge device on a local machine or in Azure. And then once we've trained that model, we can convert it to the ONNX format and push it to SQL Edge, where we can then use the predict function in T-SQL to exercise that model and do on-device ML. So this gives you some flexibility to develop models and the tools of your choice, and then convert them to the ONNX format so that you can execute them right within SQL Edge. Okay. So I've covered some of the interesting features. We're going to do some demos next here. You know, the goal here that the story I hope I've conveyed to you here is that this is still SQL Server, but it's optimized for IoT-based workloads and enhanced with some special secret sauce, or some special sauce rather, that we don't quite have in the standard flavor of SQL Server, right? And so let's go jump right into some demos. I think I've talked enough, right? You want to see some demos of how this works, how to make it actually happen? Okay. So you might be wondering first, I'm going to jump out of this, and I'm actually going to switch now to duplicate my screen because, yeah, we're done with that. Can we see the screen up there? Perfect. Okay. First thing I want to show you, by the way, just to give you an idea about what we mean by edge devices. If you've never seen an edge device, we have a couple in the Azure Stack Edge offering. This is just a snapshot of the website, but these are the kinds of devices that you can expect to see. So it might be just a 2U server that fits into a rack, or even a 1U server. Or notice we've got some devices that can even fit into a backpack, battery-powered devices that fit into a backpack that you could carry with you as you go out into the field. This is what we mean by edge devices, right? So the sensors themselves are generating this data and then streaming it to some kind of a device. And these devices are running a Docker runtime that would run containerized apps and a containerized version of SQL Server. And this is where Edge lives, is on these actual devices. SQL Edge would live in a container on these devices and process all of that data. Okay? So since it's a container-based solution, and if you'd like to check this out for yourself, here's where we're going to start with our demos. We're just going to go and actually build a local container version. Oh, come on. Why is that not behaving for me? Let's see. There we go. All right. So we're going to start with the first and easiest way for you to check out SQL Edge. You don't need one of those devices. You don't need to go deploy anything in Azure. If you're familiar with Docker and containers, you can go grab the Docker container for yourself and see what SQL Edge has in it. So I'll start with a brief demo of how that part works. And what I've got running here is just a simple demo with a very secure password. And I'm just mapping out a local path on my local machine here with some PowerShell. that will go and create a directory so that we can host the container image that I'm going to spin up. And so this is coming from the Microsoft Container Registry. And we're going to pull using the latest tag, the latest version of SQL Edge. And we publish this twice a year. That's our current release cadence, is twice a year. Right now, we're still building a roadmap for the next set of features for these things. So I'm interested in your feedback in what you'd like to see in the next version of this. But we are always including things like security enhancements. And then as features get added to SQL 2022, for example, they eventually make their way back, just like with Azure SQL, they'll make their way back into a SQL Edge type of scenario. But we're on a twice a year release cadence for these. All right, so what we're going to do is essentially just pull that container image. I'll just run all of this code. Okay, and what this should have done is just pulled code. Oh, you know what? I think I am in actually a, oh, that's why. I dropped my Docker container right before this, and so I could show you how this works. And it looks like VS Code thinks I'm still inside of that. So here we go. Let's try that one more time. All right. So this is going to reach out to the internet. It's going to try to pull a container image. And I've already done the work since we don't have great bandwidth here of pulling the latest image. But you can expect to see something along the lines of, I pulled some data down. I pulled the various layers for my containers down. I'm just using the Docker runtime for Windows. You can get this yourself. It's free, and try this out. So the next thing I'm going to do is actually create a container. And when we do that in Docker, I'm just simply going to run a Docker container using Docker run. And we have to pass a few environment variables in here. We have to accept the license agreement. We have to provide the SQL admin password. We also have to provide a machine name and do some port mapping. So that's what this -p is all about. I'm mapping my 1433 on my local machine to 1433 inside of the container so I can actually connect to it from my host. And then providing some volume persistence here as well to map to a backup directory. Okay. Now I could run this one to start this container, but I'm going to add one more interesting piece to this, which is a little bit unique to SQL Edge. What if I have a database that I'd like to spin up along with this, right? Databases in SQL, in Azure SQL, the portable format would be backpacks. So if I'd like to get a jump start by spinning up a database I've already got in a backpack format without having to go and connect to my container and restore a database, then I can provide a backpack along with this. And you're going to see why this is important a little bit later when I actually connect to deploying via an Azure scenario. This allows me to get a jump start. So if I need to go deploy a new SQL Edge instance out to a new device, let's say I'm spinning up a new manufacturing floor or I'm upgrading or something along those lines, I can provide my backpack so that it will automatically get restored when I create that Edge device. So I'm just going to go ahead and I'll run this container. Okay. And then I'm going to hop back over to Management Studio so that we'll see in just a moment it should spin up and connect. Oh, when I provide the right password. Hang on just a moment. There we go. By the way, how cool is that? How fast, if I were to ask you to go spin up a new SQL Server instance, fresh installation, how long does that usually take, right? You have to run through the setup. Even if it's an unattended installation, you have to run the setup. You have to wait for things to deploy. And then maybe 20, 30 minutes later, you've got your SQL instance. That was what, less than a minute? And I've got a full-fledged SQL instance up and running. Right? So there's some pretty cool stuff in here. Let's go run a couple of commands in here. And I'm going to do this actually in Management Studio. I'll just run a quick add server name so we can see I'm not lying, or add version so we can see what this actually is. And there we are. Just like that, I pulled the container image, I've run it, now I've got SQL Edge running in Developer Edition on a Docker container on my local machine, and I can start playing with this. Now you can go do this as well. We've got full instructions on our documentation for how to pull these container images. So maybe this is a great excuse for you to try out containers and to get acclimated. We have the full-blown SQL Server in containers too, by the way. But remember, this is SQL Edge. So there's a few things that aren't quite here. And so let me show you that list also, because you're probably wondering, okay, what's the difference? And as you can see on the list, and I know it's a little hard on the screen up here, but we'll just zoom in. So it is a reduced surface area. Remember, we said we optimized this for low-powered battery-backed kind of devices, so it's not going to be full-featured. So no in-memory OLTP. Data types that rely on .NET data types, for example, like hierarchy ID and spatial, are not going to be there. Stretch DB, that kind of makes sense. We're processing data on a local edge device. We're not going to have massive amounts of data. It's usually limited in storage capabilities. Stretch DB just doesn't make sense there as well. Full text indexes are not there. File tables, file streams. In the database engine itself, I'll pop down lower. Things like replication, polybase are not going to be there. Java and Spark integration, machine learning kind of services through Java and Spark integration. Active Directory integration. Remember, this is a container running Linux, so it's going to be limited to your authentication that Linux can provide. So it's usually going to be SQL authentication in this case. Auto shrink's not there. Database snapshots. You get the picture that a lot of the features that are there in Enterprise SQL, we've stripped out of Azure SQL Edge. We just don't need them. It's not appropriate for edge processing kinds of scenarios, persistent memory, and the list goes on and on and on for some of these. The SQL agent is there, so you can create jobs in the SQL agent, but certain parts of the subsystem are not there. So command exec, PowerShell, for example. It's Linux. There's a bash shell on the inside of it that you can use. Okay? So we saw that I can spin up, using a backpack, a local instance. I can start playing around with these features. But how do I actually use this out in the field? Let's go one step further, and let's talk about what this looks like in a more real-world deployment. So after you've gotten your hands on this to play with it, and you've said, hey, I really want to go deploy this to, say, a device that's running in my data center, right? So what we're going to do is hop over to the Azure portal, and I'm going to set the stage here. I've created a VM that's running out in Azure, and it's running the Docker engine. It's just a Linux VM. It's running Ubuntu 18.04, and it's got the Docker engine already pre-installed, and I had to, as a prerequisite, install the Azure IoT framework for this. So there's some components, some packages that have to be deployed. Effectively, what that means is that it's running some containers that allow it to talk to Azure and to accept deployments that I can initiate from the Azure portal. Out in the real world scenario, once I've created this, remember this is part of the Azure IoT framework, so once I've deployed this and connected this in Azure, I'm not just going to go spin up a Docker container locally, because I need to manage this from the Azure portal. I might be deploying this across hundreds of devices or thousands of devices that are out in the field. So we're not going to do that one-off by connecting to each one and running Docker like you would for a local environment. That's great for development purposes. Instead, we're going to use the Azure portal. So that sets the stage. I've got effectively an edge device that's running out in the cloud. Okay. So what I'm going to do, here's our Edge IoT hub that I've created already. And this IoT hub is also a prerequisite. And so if we look at the IoT Edge devices that are in the hub, we can see there's my VM that I've already pre-registered. Okay? And what I'd like to do now is actually deploy a SQL Edge instance running in a container to this Edge device that I've already got out in the that's running on this VM. So I'm going to go ahead and create a resource in the Azure portal. And I'm doing this manually, but this is all ARM-based deployments. So if you're familiar with ARM templates, you can use a templated approach. You can also use the API. So you can use Azure CLI, or you can use the PowerShell commands for this. But I'll show you the manual way to do this. So what we're going to do is create a SQL Edge resource from our marketplace. Thank you. And here's our Azure SQL Edge offering. And I'll just go ahead and I'll put out a developer version of this. there's two versions. There's a full-blown production version, doesn't have any designation, it's just Azure SQL Edge, and then there's developer version. So I'll just go create the developer version for this, and we're going to deploy this to a device. And I have to find my device. Since I've already created my device called the SQL Edge demo, I'll select it. And then we'll go ahead and we will start filling in the blanks for the deployment that we need. Okay? So I'm going to go ahead and click on Azure SQL Edge to expose the blade for this module that I'm going to go deploy to my device. And some of these things should start looking familiar here. If we look at our environment variables, for example, we saw these when I was spinning up a Docker container locally. These are the exact same things that you're going to use to deploy deploy Azure SQL Edge modules out to edge devices out in the field. The LCID is the language ID. I have to put a password in here. Let's go ahead and just do that. So, oops, here we'll type in a password. It's highly secure. Right? And if there's any other environment variables, the backpacks, for example, that I'd like to deploy, I can upload backpacks to a blob storage, and I can point to the blob storage for those backpacks so that when I deploy these modules, it can pull from that blob storage. Or if I have, in the case of a device that's running, I can also have the backpacks already preloaded on the device itself, and using volume mapping in Docker, then it can pull from those backpacks and restore those databases. Right? This is not a full-blown tutorial on how to use Docker, but essentially that's how you'll do it, is with volume mapping. Okay? We'll go ahead and I think I've got everything I need. We'll go ahead and click on routes. We're not going to define any routes for this specific demonstration, but routes allow us to specify routes for communication between IoT devices. For the demo, we'll just go ahead and create it. And remember, I said this is ARM template based, so I could take this JSON document and use this as the basis for deploying more devices. We'll just go ahead and create this, and this will now go and deploy this out to my IoT device that I've got running. Okay. So if we look at the device ID, what we'll see is here's our Azure SQL Edge that's been deployed out to and running on that device. Now we're going to go really daring here, and we're going to see if we can connect to this device. What I'm going to do is just SSH into this device and verify that my Azure SQL Edge is running on it. Okay. So let's see if this will work for me. And look at that, I've actually connected now with SSH. And I am now on that Linux machine that's running out in Azure right now, that's running the Docker runtime and has my SQL Edge. So let's go ahead and let's just make sure that everything is running okay on this. We're going to use the sudo command because we have to run in effectively root mode, super user mode. And we're going to run some commands, pre-run some commands here that just show us that the IoT Edge devices are all running okay and everything looks okay. Right, so we get some feedback that it looks like our Edge device is up and running. It can talk to Azure. It's good for deployments. Everything is awesome. We can also list the modules. So there we see that our Azure SQL Edge, just like we saw in the Azure portal, we're running the latest version of the container that we pulled. So just like I did locally on my own machine, now we're just doing this on an IoT device that's running out in the wild. In fact, I'm going to go ahead and actually run some bash commands. There's a bash shell inside this container that's running. So I'm going to run some bash commands and just run SQL CMD and connect to this device. Okay. So now I'm actually inside. This is like Inception. I'm inside my device, which is I've SSH'd into, and we're going to go ahead and just run SQL CMD now. Oops. Okay. And so I'm going to select add app version first. And there we can see, just like it was on my local machine, it's the exact same kind of container, except now it's actually running on a Linux VM out in Azure. You can imagine this could be a device running in your data center. This could be a device running in your manufacturing floor. This could be a device running in your store. Wherever it's got that connectivity to Azure, you now have a containerized version of SQL Edge out and running on it. Okay. We'll just create a database. That's why that's not working. So we'll go create a database. We will create. And I'll show you that that database exists. Okay, so there's our test database that we just created. And we can create a table in that database. We can insert some data into that, and then we can select some data back out of it. I'll just do all of that in one shot. Oh, it did not like that. Oh, we'll have to do it one time, one at a time. There we go. We'll create our inventory table in this database. We'll insert some values. And then we'll select out of it. And this is just to show you, this is SQL Server. Just like an on-prem SQL Server, you can use the T-SQL language that you know and love. You can deploy to this using backpacks, using DAG packs if you'd like, or pre-deploy using backpacks on startup of the container itself. Right? We'll just go ahead and quit the SQL CMD. There we go, and I'll exit out of this as well, so that I don't have to worry about SSH. And if you had exposed that device out to the outside world with port mapping, or maybe you VPN'd into it, you could connect to it with Management Studio as well. Now, I'm not going to do that here because I haven't exposed that device to the outside world, but you can manage it just like you would a SQL Server instance. So it's familiar to everybody. Okay. Let's do one more. Let's talk about one more special thing here, actually. We have data retention policies that are built into Edge as well. So remember, this is running on low-powered, typically low-storage capacity devices. So you're not going to maintain terabytes worth of data on an Edge device. So we've established data retention policies, or built-in data retention policies on tables, so that you can use DDL statements in order to set up your retention policy so that data will age out after an effective age. A filter will be applied to remove that data. So what we'll do, and I've already pre-run these just in a notebook, and I can make these available to everybody. To show you how this works is we're going to run an alter database statement to set data retention on. And then we can check to see if data retention is enabled for that database by looking at is data retention enabled in sys.databases. And we can see that it is turned on in our database. We can enable data retention for a table, either at the create table statement, or we can use an alter table statement. So in the create table statement, for example, you'll notice at the end, we've got a statement in a with statement that specifies data deletion is on. We're filtering on a column called dbDateTime2 that we had created in that table. And the retention period is 1 day. There's a background thread that runs in SQL Edge that will periodically wake up and look at the tables that have data retention policies applied to them, and then based off of the retention periods, will automatically delete the data from those tables for you so that it can keep your data sizes under control. Here's an example of what that would look like with an alter table statement if you had created the table and then needed to alter it after the fact. Right? And we expose this through columns. So if you select from sys.tables, there's a column called data retention period and data retention period unit. And we can see that we have in our data retention table that we just created, our data retention period is 1. That's equivalent of 1 day. And the period unit 3 is equivalent to the day, effectively. Okay. And then we can also identify the columns that have specific data retention policies on them using the column is data deletion filter column equals 1 from sys.columns. So we can see there's our dbDateTime2. And then we can also turn data retention off, both at the table and at the database. So it's an alter table set data deletion off statement, and an alter table or alter database set data retention off statement. This is unique to SQL Edge. You won't find this in SQL 2022. You won't find this in SQL in the cloud. This is something very specific to SQL Edge. Okay. How much time do we have? 5 minutes. Okay, do we have questions? Any questions so far about how this works? Wow, lots of questions. I'm going to go with the first hand I saw.
So regarding the streaming capability,
Yes.
can you have multiple Edge SQL streaming to the same database?
Yep. So the question is, for streaming capabilities, can you have multiple Edge SQL devices that are all streaming back to the same stream analytics target? And that would be a yes. You can absolutely do that. That's the intent. Imagine you have multiple manufacturing floors, and they're all streaming data back to the same centralized source so that you can provide analytics on top of that data. Okay. Next question. I'll go with the front.
Yeah, so I get the purpose of SQL Edge if you're running, for example, a number of very small sensors, like temperature sensors scattered around the building, and then a Raspberry Pi that collects this information, maybe aggregates it, and only then sends it over to the main server. But if you have with the scenario with the devices that you showed us, which have 40 virtual CPUs and hundreds of gigabytes of RAM, why would you run SQL Edge server on that device where you could instead run normal SQL server that's containerized and have all the capability?
Sure. So the question effectively is, why would you run SQL Edge on a device if you have large amounts of RAM and large amounts of storage and CPU that are available to that? And the simple answer is going to be the price associated with it. And I've got a slide I'm going to show you in just a second to close things out, because the catch here is this is the cheapest version, the most inexpensive version of SQL Server that you'll find. Okay? You're going to use the version of SQL Server that meets your needs. If you need all the capabilities like replication, where you're a publisher for replication, for example, if you need a CLR, if you need in-memory OLTP, absolutely you would run the full-blown version of SQL Server with all of those capabilities. If you don't need them and SQL Edge will meet your needs for data processing on that device, you're going to want to use SQL Edge. The question is, can you deploy the normal SQL Server with this IoT framework? So we do have a containerized version of SQL Server, but what's missing from some of this is, a key thing that's missing is high availability. That's another a great reason you might want to go with a standard edition of SQL Server, for example. The HA for an Azure SQL Edge or any containerized version of SQL Server comes from some other source. If you're going to run Kubernetes, for example, HA is going to come from Kubernetes. You're not going to get a high availability solution. There's no always-on availability groups with a SQL Edge scenario. Likewise, there's no availability groups with a containerized version, with automatic failover at least, with the containerized version of SQL Enterprise or SQL Standard Edition. So could you run it side by side? Absolutely. You can run multiple containers side by side if you'd like. Again, it goes back to deploying the version of SQL Server that meets your needs for your workload and your processing. Okay. Other questions in the back?
Most Edge be always online, or offline in most scenarios?
Well, I think the question was, most Edge scenarios are online, but can you use offline scenarios? Was that correct? Yeah. Okay. Yeah, absolutely. So the streaming capabilities are one feature, but they're not requirement. You can do offline deployments with SQL Edge as well, and we have documentation that shows you how to go do that. So you could completely train Onyx models, deploy them to the device, and then run in a completely offline, disconnected scenario, or semi-connected, say, once every couple of months when a ship shows up type of scenario. Okay. All right, I've got 1 minute left, so I want to show you the key thing here about the pricing. I had mentioned this. I mentioned this is the most inexpensive version of SQL Server you're going to find. This is $10 per device per month to run Azure SQL Edge. If you pre-commit, then you can get, for up to 3 years, you can get it down to $60 per device per year. That is the most inexpensive version of SQL Server you will find anywhere for an actual fully supported version of SQL Server. This is not just Developer Edition where you can get it and run it for free but no support, or SQL Express with no support. This is the full-blown, fully supported. If you have an issue, you can call CSS and get support from engineering as well, version of SQL Server. Okay? So I'll leave you with some getting started slides. We've got documentation that covers all of these scenarios and shows you how to do this for yourself. We've got some additional demonstrations and quick starts on the documentation pages that show you how to work with Onyx models. And we've got plenty of videos that walk you through this as well. And the last thing I'll close with is the SQL Bits team and I would very much appreciate your feedback. So if you would be so kind as to follow the links on the screen and provide feedback, let me know how we did. If you have any follow-up questions, you can reach out to me. I'll hang out in the back of the hallway back here so that the next speaker can get up, and I'll be happy to answer any more questions that you have. So thank you very much. I hope you've enjoyed it, and I hope you enjoy the rest of your Saturday here at SQL Bits.